Thank you. Yes, and I'd like to make sure I credit Jennifer Fish, who was an undergraduate and did a lot of the development work on this case study, as well as Daria Meliker, who helped to supervise Jennifer and was involved in some of the design aspects as well. So emerging languages today build in new kinds of security features. So Java is hardly new, but even I think 25 years ago when it came out, more than 25 years ago, it was notable for enforcing sound static types and for having a security model involving stack exception. And that has improved, I think, security a great deal in the interim. Since then, of course, the research community has proposed a lot of things that go beyond what the basics of what Java does. I think a great example is Java with information flow in GIF. Another one is capability safety in the language E that Mark Miller put together. And of course, now Rust is making its way into industry and integrating safe memory management based on types rather than based on garbage collectors. So these are all really cool ideas. A user might ask, why should I use these new language-based security features, right? And researchers say, well, okay, we can eliminate whole classes of vulnerabilities. But the user might say, is it practical to build systems using these new kinds of features, right? So I think it's important to step back and kind of look at these. So I can't answer all those questions, but I can start to work on an answer towards some of them. So we want to think about what kinds of programming language-based security features are ready for language designers to integrate and maybe for early adopters to use. So to find out, let's do a case study, right, to answer these questions. Okay, so the setting of this case study is the Wyvern language. It's a language that I developed along with Alex Botanin and a bunch of other people. It has a bunch of these features. Designed from the ground up to be secure. Of course, it has types, but added to that, it has object capabilities. So following up on some of the work from Mark Miller and E, but adapting it to a statically typed setting. Effect system, another area that's common in the research community. We made some innovations there, but are also kind of exploring the practical impact of effects. And language extensions, right? So extensible languages are a common theme in the SLE research community here at Splash, and we have that in Wyvern. Some work previously published in a paper at eCoop. So we wanted to look at, can we actually write libraries with these features, right? How practical are they, and how do they impact security in practice? Again, a case study is not going to be able to give a comprehensive answer to these questions, but it will give an answer for our implementation of these features in Wyvern and the particular program that we wrote for the case study. So we chose to build an I/O library for Wyvern as our case study. I think it's useful for thinking about security because just about everything dangerous involves input or output, right? You're reading a password, okay, that might be dangerous because maybe that's supposed to be a secret. You're launching missiles. Geez, I hope that doesn't happen in the real world. So we built a small standard I/O library for Wyvern and investigated, how we could use these security features. How did they enhance system security? Were there sort of barriers to using these features that could lead to future work? So the paper talks about a number of these. I'll summarize some of the high-level take-homes in this talk. And I should say, I think there's a standard set of caveats here, right? We designed Wyvern. We built this I/O library. We're the authors of the paper, right? We're kind of studying ourselves, so that's a limitation. But I think, who else is going to use a brand new language until you do some first steps? And so this is the first step. And, hopefully other people will do more case studies with other languages and maybe with Wyvern too, who knows? Okay, so let me motivate some of these features. First of all, one of the things we'd like to do is limit the privileges of untrusted code. Okay, so I have this untrusted Java file. I want to use the module, but is it safe, right? So in Java, we have a way of handling this. It's called sandboxing. But there are some limitations, right? It's actually quite complicated to sandbox things, and because it's complicated, people get it wrong. Um, the details are long, but you have to sort of put in checks at all the entrances to the sandbox, because no sandbox is actually a box. It has holes in it, and you have to guard those holes. And people forget holes, or they guard them in the wrong way. And so there's been a lot of past vulnerabilities in the Java sandbox, but also others, right? The sandbox for PDF has had a ton of vulnerabilities. It's just it's a tricky technology to get right, because you have to put these guards on all the entrances to the box, and the box is often complicated if you have a rich piece of software. So capabilities are an alternative. Okay, I'm going to use the analogy of Zeus and his lightning bolt. With his lightning bolt, Zeus can destroy anything. So a capability is the ability to do things, possibly dangerous things. And so, if we go to Rick Riordan's universe of Percy Jackson, the villain Luke Castellan can't do anything unless he can steal the bolt from Zeus, right? And there's this whole story that is built around that. So how can we use this kind of security paradigm? So introduction to capabilities. Object capabilities control privileges. So system resources are objects. The file system is an object. The network is an object. And of course, individual files in the file system are objects. Directories are objects. Connections to the network are objects. So we break it all down. So a capability is a reference, right? A reference to one of these objects. And so, our different users or our different programs here can have capabilities to these resources, just if they have a reference to them. And so actions are methods on a capability, right? We can call file system.open, we can pass the name of the file we want to open, and we can write to it. And that's something, right? We can call network.sendPacket. These are examples, but they're very simple. It's nice to see kind of this analogy between objects and capabilities, right? Because I think the object-oriented model is a very natural model. If you want to do anything on a capability, you call a method on it, which is the standard way of dealing with objects. Now, capabilities only come from other capabilities, right? That's the critical aspect of them. So our villain here, might like to say new file password.txt, and actually you can do this in Java, right? Java is not capability safe, but in a capability safe language, you can't just create a file out of nothing. You have to get a file from some existing capability, like the file system. And so in our setting, our villain will be thwarted because they can't, kind of create a capability on their own. So let's look at how this kind of works out in practice. In our design for the file system, we start with the capability to the whole file system. You can call the directory for method and get a particular directory, which gives you capability to all the files in that directory and its subdirectories. You can ask for the files, you get a list of them, and each file in that list is a capability to a single file. And then you have reader and writer abstractions, again, similar to Java, which give you read-only access or write-only access to the file. So in the capabilities world, let's say we have a module written by a trusted party. We give it the capability to the file system so it can do all the things that we need it to do. But maybe this module wants to use a third-party module, but it doesn't fully trust it, right? And indeed, perhaps our third-party module is written by the bad guy. So what we can do is we can take our capability for the file system and ask for a capability for the directory. And then we can ask the directory for a capability to a file, ask the file for a capability to a reader, and then we can pass this to our third-party module, right? Because in this case, that third-party module perhaps only needs to read a particular file among all the files in the system to do its job. So now our attacker is thwarted, right? All I can do is read one lousy file. Maybe I can discover some dangerous information there, but the bad things I can do are limited. And so this is the principle of least privilege. It's kind of built into the idea of capability systems. Okay, so let me give a demonstration that shows in a little more detail exactly how this works in Wyvern.
Here we have a program that takes two capabilities, one to the Java foreign function interface, which is kind of the Uber capability in our system, and also to standard out. We import file system as well as the entrusted module, and we instantiate file system by giving it a capability to the foreign function interface, which now means we can use the file system. We'll go ahead and create a reader, pass the reader to the untrusted code, and then print out the result. When we compile the code, it prints out, it reads conference.txt, and we find out that we're in fact in Onward 2020. Now let's look at our code. Our untrusted module is just reading, but let's say we want to do something more. For example, maybe a nefarious attacker will import the file system, instantiate it, and read the password file. What happens if they try to do this? Well, as you can see, we don't actually have a capability to the foreign function interface Java, nor do we have a capability to the file system from main. And so we fail. No variable named Java is in scope. The attacker has been thwarted.
Okay, so the demo video was recorded in 2020 when I had all the stuff set up on my laptop for it. So sorry for not doing a live one, but I think it would, actually I have 3 of these, so like trying to do them all live would probably have been a problem. Anyway, you can see the mechanisms we're using. There's actually one level above this example that I showed you, where there's like a universal capability you get from to main, which is the foreign function interface. You actually use that to instantiate the file system and the network and whatever you need. But then at that point, only main can import this Uber capability of Java, right? All the others only get what we pass them, and if we don't pass them anything, then you get, as you see, the failure to actually run things properly. Okay, so we designed kind of a minimal file system, but what's interesting is that it's missing some features because we didn't build them in. But in general, any standard library you build will have some missing features. So what's nice is that you can build them out of these primitives, and in fact that includes maybe security things you want to enforce. So you might want to have like a read-only directory access, right? I don't know if this is general enough to justify being part of an IO library. Let's say it's not, for the sake of argument. What we can do to build it is we can implement our own read-only directory. Internally, it has a pointer to the directory, but it doesn't let clients get the directory, right? There's no get directory function on read-only directory. Instead, there's a files function, but the files, rather than returning an absolute file, returns a read-only file, which just wraps the file under the covers, right? And then the read-only file you can call make reader on, and you get a reader, but there's no make writer function. So with these wrappers, it's a standard technique and capabilities. We just adapted it here. But the point is, even if it's not built in, we can build this abstraction, and we can give our third-party library perhaps directory read-only access to some directory without giving them full access, for example. Okay, so a small thing, but just it points out kind of the adaptability of a capability-based design. Okay, so some lessons. I think we were able to see some useful granularity variations. That's one of the nice things about capabilities. Just the objects you have define what you can do. It supports these user-defined abstractions like read-only directories. What's interesting is that actually, if you were clever enough, you might actually use the directory as its own read-only capability. You could just like cast it to a different interface, right? One where files return read-only files, and read-only files is like a version of file that is just missing the make writer interface. So that would make things a little more efficient, which might be helpful if these things ends up in the inner loops of functions and so on. But there's a few features we didn't have in Wyvern at the time. Covariant type parameters feature in Scala. We've been working on in a separate project making a variant of those that's decidable for Wyvern. So, but we saw an interesting use case here to make these wrappers a little more efficient and nice to use, quite frankly. So you don't have to implement these wrappers. And that's actually an advantage over typed capability systems versus untyped capability systems. In JavaScript, you can use the same trick, but you really do have to wrap it. Whereas in a typed system, we believe with some extra features, we can, including like gradual types that respect parametricity. There's a paper this afternoon on that. We could do it more efficiently and in a more clean way in a type setting. So that's a nice observation, I think. At least we thought it was cool. Okay, what else do we have in Wyvern? So we have effects. Effects provide a way of static reasoning about I/O actions. So you can have a writer and then an effect write, and then the write function can have an effect annotated on it. The motivation here is to describe in a way that we can statically verify the potential effects of a function. And by extension, we can reason about all the effects of an object by looking at the effects of its methods or a module, etc. So we can be very specific and say, this is the write effect of this particular writer. But we could be more general. So we can parameterize the writer with the write effect of the surrounding file. And we could even have like a file system that has a default write effect. If we don't want to distinguish the effects of different files, we don't have to. But these writes they're actually members of objects. So we're using a kind of dependent effects system here. Similar to dependent types in Scala, where you have type members, we have effect members. So it's a very flexible system. I think for a lot of applications, you're just happy to say, I'm writing the file system, but if you want to be more specific, you can using these abstractions. So what can effects do? So one thing they can do is identify suspicious app changes, right? So let's say I have a save function and a post function. And the save saves it to the network file system, posts it to the network. If we have unexpected effects, it might be suspicious, right? So if we modify save and it actually writes to the network, okay, maybe that's intentional because we want to save it to a network drive, but maybe it's suspicious, right? And so we actually get warned if there's code that depends on this and it has its own effects, and then you change these, you get a warning. And maybe you have to look at that other code and see, is this still safe, right? Is this still doing what I expect it to do? So here's a little demo of how we can warn of changes like this.
Here we have save, which has a file effect, and post, which has a network effect. If we compile things, everything works as expected. However, if we go ahead and change the save function so it actually posts, well, that might be, first of all, surprising, but it might be a security risk, right? We're expect to only write something to the local file system, but we're writing something to the network here. If we compile again, we'll get an error message. And the error message actually comes because we have other code that calls save, and that code that calls save only expects to make a file have a file effect here, edit, right? It has only file effect, but that has now changed because the effective save now has a network effect.
Okay, so it's a way of capturing effects, and then when things evolve, you get notified. I guess from one perspective, this could be it could be a barrier to evolution, right? That you have to update these effects. But from a security point of view, you probably want to know about this. And if you actually don't care, you can be parametric in the effects in our system. So that's I think that reduces a little bit of the evolutionary burden. We did discover some things that were challenging. Like our capabilities, our effects derive from kind of a global effect. So we have a system.ffi effect, which is what happens when you call an FFI. And initially, read and write are both like FFI calls, but we'd like to be able to distinguish them from the point of view of clients of this library. How can we actually do this? There's a solution to this from the typing literature, right? And it's called, it's basically bounded polymorphic types, or bounded type members, again, as is provided in Scala. So what we like to say is not that write is equal to system.ffi, but we like to expose an interface that says write is a specialization of system.ffi, and read is as well. So now these are actually distinct. They might be both just equal to system.ffi under the hood, but from outside you can't tell that, right? So we have a layer of abstraction, and that forces clients to keep them separate. Whereas while the implementation still type checks because they actually are both equal to system.ffi kind of under the covers. So the key study kind of motivated a new feature. We implemented it. We actually used it in the case study, and we've published it since. So this was not in the Onward 2022 talk, but you can look up our bounded abstract effects paper in TOPLAS that came out earlier this year. Okay, last bit, language extensions. So language extensions are often viewed as like a more convenient syntax, but they can also have security consequences. In particular, using languages within strings causes problems, right? Command injection, format string vulnerabilities come because you have a language that you write inside a string, you write a SQL query inside a string, and you paste strings together, and maybe someone can inject commands into your language into your string in an unexpected way. So language extensions that are not just strings can forestall these problems. And what's nice in Wyvern, as in some other kind of state-of-the-art research on language extensibility, this can be imported as libraries. So we had an EQ paper a few years ago that covered our particular approach to this. So I'll give you an example of format strings. And you can't even express a format string vulnerability in this language. So here's a little example. You require standard out. There's one more requirement that actually is shown in the demo, but it's not on the slide, that pulls the metadata language into scope. But we can basically printf and paste a string safely into hello, and we say hello world. So what's going on here is we have this tilde tells us that there's a special language that's going to be used as an argument to this printf. And rather than put it inline, we put it indented on the next lines. So the indentation, Wyvern is an indentation-specific language, and the particular language being used here is that this whole thing is a string, but whenever there's a percentage, we paste in another string or an integer or floating point or Boolean in some safe way. So it doesn't, I guess the point is that this is a string, you can't have another percentage inside it, for example. That would be dangerous. So similarly, you can do a printf and say, hey, the sum is y plus 5. We have an expression here. We can put in Booleans. We can put in floating point numbers, and it prints out kind of the thing that you would expect. So what's kind of nice, so Python and some other languages actually have strings, special strings that you can put things like this into. But what's kind of nice is that nothing's built into the language. It's all in a library. And so we did it for format strings. You can do it for SQL. If you have another language, you can make it work for that just as well as the built-in things in other languages. Okay, so final demo.
We first import the format string library, and we import metadata, which brings the language into our context. Now we can define a conference variable with onward, and we can print the conference. The value of the variable gets pasted in a safe way. And notice that because we show where the pasting happens, and we give the expression right there, we can't do the C problem where we give too many format specifiers in the format string and then not enough values for it, which is the source of a format string vulnerability. We can, of course, also print integers and floating point numbers, as well as Booleans, but one thing we can't print is functions, such as this ID function. As you can see, we get an error message saying that the expressions inside a format string must be of type int, string, float, or Boolean. Now, if we go and fix this and we put a value in instead and recompile, then things work as expected.
All right, so what you saw there is that there's actually there's some type checking extensions in that language extension library, right? So it actually does type checking and makes sure the things that you're pasting in are things that it knows how to convert to strings. All right, so some takeaways, right? We looked at some of the features of Wyvern capabilities and support the principle of least privilege. Effects support static reasoning about I/O actions. Language extensions mitigate command injection. So we basically showed some scenarios where we can use all three of these. We also found some places where things we needed some improvements that motivated some research, which I guess at least one of the follow-on research was now published since Onward 2020. But anyway, it's one language and one set of features, but we hope that other people who are maybe considering using some of those features in their own language could use this, could learn from our experience with study and build better languages for the future. So with that, I'm happy to take any questions.
Cool. Thanks for the great talk. Do we have any questions from the audience here? And I'll also check Jeremy if anyone's on there.
Yeah, that's interesting. So capabilities are verified at runtime and effects are verified at compile time?
That's right. Yeah, capabilities are it's object capabilities, so it's a runtime thing, it is a good point because some people are now using capabilities for static things as well.
Could you?
Could I? So you can.
Yeah,
I think the key question is the system flexible enough if you try to do this statically, right? I mean, if our effects system is a bit of that, but I would say, our effects system is not as flexible as what you can do with the runtime capabilities. So, the nice thing about a runtime capability is you pass it around just like an object. And so it supports a lot of very flexible composition. So I think at this point, I wouldn't want to get rid of it entirely, but some researchers should try it and see how far they can get with it.
Other questions? Yeah.
Yeah, so it seems like language extensions are, that's cool. I was especially interested in the extensibility part. It seems like language extensions in Wyvern can, so obviously they can introduce their own syntax into the language, but they can also integrate with type checking. I was kind of wondering how difficult it is to write a language extension for Wyvern, like what the process for that looks like, I guess. Yeah,
that's a good question. We haven't worked to make it easy. I think a strength of, say, the Scheme Racket community, for example, has been actually working on a lot of infrastructure that makes language extension really truly easy. Our focus has been a little bit more on kind of clean syntactic integration and type integration with the host language. So we're kind of pushing in that direction, but not so much in making things easy. But I think, in practice, you want both, right? I think we focused on this partly because of amortization, right? Even if it's a little bit painful to write extensions, if a lot of people use them, you can get a lot of value out of them.
Yeah, I was mostly curious because in Rust, the fair print function can part of the checks you do in Wyvern. So if you check the arity, it matches up, but it can't do the type checking, which is really nice. The offset being, of course, that the print function is just a macro, so it's kind of easy to write. But it might be interesting to explore, like can you integrate type checking into this sort of like how easy is it to talk to the type checker and use a written language extensions?
Yeah, it's a great question. So I can give you a summary answer, which is basically you get it's sort of a reflective call, right? So you get an AST, well, you get, at the basic level, you get just a string. You get a string with the white space stripped off. You can do anything you want with it for the language, but you have to code it up yourself. So that's one thing where macros kind of do a lot of the parsing for you, right? But you can do anything you want with that syntax. You provide an AST as the result, and you're also given like a context, which is basically, the variables that are in scope. So you can do type checking and then an interface to report an error. But it's a pretty basic interface at this point, just because we haven't focused on making that flexible and easy. I guess it's flexible, but it's not easy.
Cool. We might have time for one last question while Patrick picks this up if anybody's got one. Yeah.
Thank you for the very nice talk. I was wondering about the capabilities, like how granular they are. You say you have objects, so are they at the object level? Can I use these capabilities for fields? Can I play around with composing them, or it's
Yeah, they're objects. So any kind of composition you can do with objects, you can do with our capabilities.
Yeah. So say I have an object.
You're next.
I think Patrick's third. Yeah.
Yeah.
Sorry.
Just take this offline and we can discuss later. Yeah.
Okay. Yeah.
All right. Let's thank the speaker one more time. Thank you very much.